So in this video, we're going to be talking about house robbing problem. So given the input of houses, essentially just an input of numbers, our goal is to maximize the amount of money we can rob from all those houses. And the two rules are, one, we can't rob two houses adjacent to each other. And two, the first and the last house are connected together, so we can't rob them at the same time. Okay, so now let's take a look at another example. So we have an input 1, 2, 3, 1, and 5, and the best output turns out to be an 8. And the reason why it is an 8, we have to follow two rules. First, we can't select two elements adjacent to each other, so we can't select 1 and 2 at the same time. If we were going to select 1, we have to skip to 3, and so on and so forth. And the rule is the first and the last element are adjacent to each other because they are linked together. So we can't select them at the same time. So that's leave us to select 3 and 5 together, and that's give us the best answer output of 8. Alright, so I drew this table in order to do a bottom-up approach by first looking at the first element and using that result building up on the second element, third, and so on and so forth. So let's fill in our first base cases, which is the first element. So as you notice, we have two rows. The first one, which we will take the first element, and the second row, we will skip the first element. And the reason we want to do this, we want to try a different combination and see which one will give us the better answer. So in the first element, we have 1. So if we were going to take the first element, the best result so far is going to be 1. If we skip it, it's going to be 0. So let's look at the second element, 2. So at 2, because we already took 1, right, on the first row, so we can't take 2 because they're adjacent to each other. So we have to just propagate the best answer from 1 forward, right? So the best answer is 1. On the second row, which we skipped the first element, we can take 2, right? So we have two options. Either we take 2 or we skip 2. So let's take a look. So if you take 2, we get 2 plus our answer, right? So because we don't have anything that comes before the first element, so we get nothing. In this case, we plus 0. However, if you skip 2, we get a 0, and we're going to propagate the best answer from the last one, right? Which is in this case is this one. So it's also going to give us a 0 plus 0, which gives us a 0. So the best answer here is 2 so far. So let's write it out nicely. At 3, we can't take that because we already took the first element here, which is 1. However, if you look at the second one, we can't take it either because 2 is adjacent to the first element which we took. That's leave us, the only option is to just propagate the answer forward. So which is also going to be 1 as well. But if you look at the second row, which we skipped the first element, we have the option of taking 3. So now if we took 3, right, we can use the best answer from the first element. We have to skip this element over here because it's adjacent to 3. So this first element is a 0, so we can have 3 plus 0, which is going to give us 3. But however, if we skip 3, so we have nothing, we have 0 plus the best answer from 2 over here, right? So that's give us a 2. So the best answer here is 3. So let me just erase that and put a 3 in here. Alright, so this is where it gets a little bit interesting. So here at 1, we have the option of taking 3. Remember previously we can't take 3 yet. We can take 3 here because 3 is away from the first element which we are forced to take, which is 1. So if you take 3, we can go ahead and take that and add that to the second element, which the best answer is 1. So let's give us a 4. Or it gives us the option of taking the second element, right? But however, the second element is adjacent to the first element, so we can't take that 1. So the only answer that we have on this one is going to be 4. So let's clean it up and write it 4 here. On the second row, if we take 1, right, we can take the best answer from the second row, which in this case is going to be 2, or we skip that, which is 0, and it just propagate the answer from this one, which is 3, So both of the option will give us 3. So the best answer here will be 3. So let me write that in. Okay, so lastly, we have 5. So at 5, we can take 1, which is okay because 1 is far away from the first element over here. So if we take 1, 1 plus 1, that's give us 2. Or we can take 3. We can take 3 and add that into the second element, which is 1. So 3 plus 1, which will give us a 4. Alright, so it looks like the best answer here is 4. Let me write that in. On the second row, if we take 5, we have to skip 3, but we can take 3 here, so that will give us an 8. If we skip 5, we take 0, and we just propagate the best answer from the previous answer, which is 3. So it looks like the best answer here is 8. So let me put 8 over here. There you go. Alright, let's talk about runtime real quick. So at runtime, because each element has to inspect at least once, that's going to give us the space complexity of big O of n. For the space complexity right now, because we keep track of the table where there are exactly 2 rows, that's going to give us the space complexity of big O of n. Alright, let's code it up. We're going to have 2 caches. A call cache, we're going to take the first element, and a put cache, we're going to skip the first element. Next, we're going to iterate over each of the elements in our arrays, starting from the second element, and initialize the current call position to the first element in order to compare it with the previous position and the second previous position and take whichever one is the greater number. For the put cache, we're going to compare and take the greater value between when we take the current coins and when we skip the current coin. And lastly, we're going to return back the greatest value between our put and our call caches. And that's about it. Thanks for watching. Thumbs if you like it and sub if you love it.